Hello and welcome to Deep Learning with Apache MXNet. In this video series, we are going to actually explore the MXNet Deep Learning Framework by Apache. And in part one of this video series, we are actually focusing on some of the characteristics that actually discriminate MXNet from other deep learning frameworks. And we will also see how to install MXNet, and we will see a hello world using MXNet. So first of all, what is MXNet? Well, MXNet is a deep learning framework, and it is by Apache. Actually, it started in it actually initiated in 2015. The first release was in 2015. Then in 2017, it was incubated by Apache in Apache. And then from then on, Apache actually is now, the license is given by Apache now. And it's a great kind of deep learning framework that I will explain some of the features shortly. So the very first question is why, this MXNet framework is actually, what are the characteristics that makes MXNet different from, for example, TensorFlow and PyTorch and other frameworks that are existing? Well, several frameworks, either most of them, they support imperative mode of programming in programming deep learning models, or a symbolic style. By imperative, you can rename the imperative like the interpreter. Maybe that's a bad name, but just to understand in layman terms, interpreter. Or you have a sequence of statements. They execute one by one in completely native language. For example, if you're working in Python, then imperative mode will be working completely in Python. All the programs, they will be dealing with in Python. So line by line, statement by statement, you can execute and you give the result. The benefits of imperative mode programming is you can debug and you can actually see what is happening at each statement of the code. In deep learning, however, your computational graphs normally are very complicated, and I mean, they are complicated and they are large in size. And staying in imperative mode has some optimization problems, speed up problems, and these kind of stuff. So on the other hand, the symbolic style of programming actually does not execute each statement as it is written. Rather, it actually store all these statements as placeholders, and it actually execute all the computational graph once when all these things are defined. So like it is recording what is going to happen when it will execute, but it is not going to execute this until the compile time, or there may be some command like compile or some other way. So what happens basically is, in imperative mode, the statements are executed as you move on in the computational graph. So let's say this is the unfolding of the computational graph. In symbolic mode, these statements are not executed, rather their operations are being recorded. And whatever finally you are going to achieve, the whole computational graph is actually executed once in the so-called compilation layer, although that might be a confusing name. But most of the programming, most of these deep learning frameworks, including MXNet, what they do is they have their backends written in very fast languages, in the compiled languages. For example, MXNet has its backend written completely in C++, which is really, really fast. So which means that whole execution of your deep learning model, the training of your deep learning model, is really fast in symbolic mode. So the problem with symbolic mode is it is really hard to debug what is happening along the way, iteration by iteration, or at different pieces of the code, what is happening, what is going wrong, if something is going wrong. So debugging actually in this symbolic mode really becomes difficult, although it speeds up a lot of stuff for you. So what MXNet comes up with, it comes up with both imperative and symbolic styles. Actually, it has hybrid style as well. So, for example, by default, you start with interpreter or imperative style. And when you, for example, have run a few iterations or few epochs of your model and you are satisfied with this performance, you can completely switch to symbolic mode, which is much more faster. So, and that is so easy to implement and easy to handle in MXNet. That actually discriminate this MXNet from the other deep learning frameworks. So that's one very powerful characteristic of MXNet, that it supports both imperative and symbolic. And it has a very easy way to switch from imperative to symbolic mode whenever required. Then another property of MXNet is it is really, its scalability to distributed environment is really great. So for example, if you compare the efficiency with respect to the number of GPUs, let's say the number of GPU is one measure of the quantity of distributed environment, then actually on several recent models, it turns out that the efficiency with respect to the number of GPUs, it actually is almost linear and is close to ideal efficiency. Which means if you are getting your GPU, if you're getting more and more GPUs, the efficiency using MXNet will scale accordingly. And this scalability is also very powerful property of MXNet as compared to the rest of the deep learning frameworks. It just not supports Python. I mean, it comes up with a lot of with a very high support of a lot of languages. For example, it supports Python, it supports Perl, it supports Java, Scala, Julia, R, C++, and a couple of others. Let me show you. It actually supports different languages, different operating systems, GPU or CPU environment. You can install it using Docker, pip, and from source. Let me show you some of its variants. This is the homepage of variant 1.6, and let me show you the different kind of so variant 1.6.0 platform. You can choose Linux, Mac, Windows, cloud, or different devices. For example, let me choose Windows because I have Windows machine, for example. Then on Windows, for example, it supports Python, Scala, Java, Clojure, R, Julia, Perl, and C++. Let me choose Python. And then I can choose, if I have GPU installed, I may choose GPU variant, or right now in my machine I don't have GPU, so I will use CPU variant. Then I can install using pip, Docker, or build from source. For example, I go for pip. Then I mean, these are the variations. I mean, these are the supports that are available for this, and it is saying, okay, go pip install MXNet and everything will be okay. So yeah, it has supports for several languages, several operating systems, and several of these kind of combinations. Then it is trusted by and is used by very renowned kind of institutions. For example, Carnegie Mellon University, Massachusetts Institute of Technology. It is used by University of Washington. So University of Washington. It is also used by University of Hong Kong University of Technology. It is also used by Stanford University. I mean, a lot of very renowned institutions, they are using MXNet now. Not only that, it actually AWS, Amazon Web Services, they actually have chosen MXNet as a deep learning framework of choice. So, and it has a lot of reasons. I mean, AWS, it is working with cloud. It is actually cloud services provider, and it is actually providing the hardware and software support for distributed computing. And MXNet indeed have this kind of scalability that discriminates this with from the rest of the frameworks. And AWS has some biasness to actually chooses this MXNet as a framework of choice. So, and it has many more properties. I mean, it's very flexible. It's portable. You can build a model on one language, then you can make inferences in another language, and I mean there are so many things. So after seeing a lot of beautiful characteristics of MXNet, let's go and see how to install MXNet. So for example, installing MXNet on Linux and Mac OS is relatively simple, but it's also simple installing on Windows as well. So here I have a Windows machine and I already have Anaconda installed. The version of Python I'm using is 3.8. It's kind of a latest version. It is always good to make new environment when you are, I mean, for example, if you're working with TensorFlow, I will recommend to make a new environment for all the packages and the supports required for TensorFlow. If you're working with PyTorch, make another environment. So it is good to make environments. So let's make an environment for MXNet. So conda, create a name. Let's say, what should be the name of the environment that we are going to create? Let's say MXNet, MN. So let's say that's the environment name. So it may create that. Yeah. So now the environment is available. It has been created. Let's activate that environment. Conda activate MN. So that is activated. Now in this environment, I'll be installing MXNet. So pip install MXNet. Oh, pip is not available in the new environment. So let me install pip first. So conda install pip. So it will take some time to install pip. So yeah, let's wait for that. So after pip, we will be able to install this. Yeah, so let's wait for its execution. I guess it's done. So now let's install pip, install MXNet. So yeah, so it is actually installing this MXNet, collecting from internet the required packages, and it is installing these packages. One problem that you may come up with if you are working in Python 3.8, one problem that you may come up with is you may encounter a build error for NumPy here. And for that, I will recommend to actually download and install Visual C++ build tools. So C++ build tools, install those, and that error will go away because the NumPy actually is built here. So that's why it requires that. So now everything has been installed. These are certain warnings for some dependencies. I have TensorFlow installed in my base, so but either way, that's okay. Now I have to install Jupyter because Jupyter is also not available. So install Jupyter, pip install Jupyter. Yeah. So let's see what it does. It may take some time to install Jupyter, and once the Jupyter is done, I guess we will be ready to go and write hello world in MXNet. So let's see. So it may take a couple of minutes to install these for the very first time. So let's wait for it. I should point out one more issue with this Windows and particularly these the earlier issue of if you're getting error of building NumPy, that is also on Windows. For that, you have to install these Visual C++ build tools. Another thing that you may encounter while installing on Windows, that's not a problem on Linux. That you may have your you may have a kernel error when you start Jupyter Notebook. You may or you may not have a kernel error, and that is due to PyWin32 DLL. And if that has an error, we may have to. So, for example, if you focus on this PyWin32, if its version is not compatible, you may get a kernel error. In that case, we have to downgrade its version, and we will be good to go. And if it is already compatible, we will be good to go from here. So let's see, all set. So Jupyter Notebook. Let's see. Let's write our first program, Hello World, in MXNet. So new Python 3. Oh, you get a kernel error. I told you that there are some problems of these kernel errors. So what should we do? Well, on Windows, you can downgrade that. For example, in Python 3.8, PyWin32 225, actually, the version 225 works well on my machine. So let's go about that and do that. So pip install PyWin32, and the version is 225. So what it will do is it will uninstall the latest version, which is 228, and then it will install some older version, 225, and maybe that brings the required DLL that we need. So Jupyter Notebook, I guess things should work now. Everything's set. So yeah, fine, no kernel error, kernel is ready, great. We can name this as MXNet Hello World, Hello World. So that's the name. We can just get rid of it. We can have this larger. Let's import MXNet as MX. So, and then let's print its version. Print max dot version, and that's 1.6. One thing that I want to mention is MXNet has its own ND array module, which is ND, which is much similar to NumPy if you have already worked with NumPy, but just I want to get you familiar with ND. So for example, from MXNet import ND, and now you can just work like with ND, you can just work like you are working with NP NumPy. Most of the things are similar. For example, x is equal to nd dot array. Let me make an array of 1, 2, 3, and then let's say we have 4, 5, 6, and let's say that's a two-dimensional array. This, and if you see the type of x, that is MXNet ND array, and if you just display that, it will be displayed like so. If you access a particular element, was that name x? Yeah. If you access a particular element, for example, 2, or 0, 1, it will give you element also in terms of ND array. You can go back and forth from ND array to NumPy array and vice versa. For example, you can have import NumPy as NP, and now you can have, for example, b x or y as x dot as NumPy. And now if you see the type of y, that is a NumPy array. And now if you access particular elements from there, let's say 0, 1, you will get real numbers. And you can go back as well. For example, z is equal to nd dot array y. And so from NumPy, you can generate the ND array. From ND array, you can go back to NumPy. And most of the data manipulation in MXNet is handled by this ND arrays, and the tensors are generated in terms of ND arrays, which has broadcasting, slicing, and all the support that is there in NumPy as well. So that's the installation and motivation for MXNet. In the next part of this video, we will actually be building a neural network in MXNet. And we will be building a plain neural network like we did in our TensorFlow video tutorial. First, we build a plain neural network in MNIST dataset. And then in the last part of this video series, we will be actually building a convolutional neural network. So hope to see you next time.